Okay, so today what we're going to talk about are more exponents, but we're going to talk about them in the frame of what some of you have kind of started wondering about, which is the idea of what does it mean when you have a fraction as an exponent? What does x to the 3/2 mean? What does 17 to the 1/2 mean? What does 27 to the 1/3 mean? Okay, we're going to figure out what exactly that represents. So, if I were to give you x to the a over n power, we can think of that in two very similar but slightly different ways. Okay? We can think of that as the nth root of x to the a power or we can think of it as the nth root of x raised to the a power. What I mean by nth root is like the cube root, n would be 3. The fourth root, n would be 4. It's like the little number inside the radical that you see.
Okay, so if like n was 2%, how would that affect these three?
Well, let's see some examples and see if that'll answer your question, okay? All right, so a, the numerator, is the power that you're going to raise your base to. When you have a fractional exponent, n is the power you're going to raise your base to. N is the root you're going to take of that base. Fourth root, fifth root, cube root, square root. Okay? Another root for root is index. The little number that you see outside of that radical is also called the index. So the index of a square root would be 2. The index of a cube root would be 3. Okay? So look at number 1. We're going to convert this back and forth between rational exponent notation and radical notation. So I have the fourth root of x to the 7th. Okay, so my power is 7 and my root is 4. So I take my base of x. 7 is my power, so that becomes my numerator, over my root, which is 4. These two mean exactly the same thing. All three of these statements mean exactly the same thing. Okay, Lindsay?
Is there any difference between like this or that?
One more time?
Okay, see how you drew it? And it's just like a check mark and then a line. But is there a difference if it's like...
Oh, you're saying is there any difference between that or that?
Yeah.
No. Okay, look at number 2. I have the fourth root of x. What power is implied here? 1. So how could I rewrite this? X to the 1/4. So the fourth root of x means the exact same thing as x to the 1/4 power. Okay? So how do you think we could rewrite the cube root of x? Yeah, that's the exact same as x to the 1/3 power. What about the square root of x? Yeah, what number is implied here? 2. So it's a square root. So that means the exact same thing as x to the 1/2 power. So you want to start noticing these connections and being comfortable with them. When you see a number to the 1/3 power, that's the exact same as asking for the cube root of that number. When you see a number to the 1/2 power, that's the same as asking for the square root of that number. That's why you couldn't really do number 21 on your homework last night, because you had to understand, what does the 1/2 power mean? What does it mean to take x to the 1/2 power and get 1/3? Well, that means what is the square root of something giving it 1/3? Yeah.
Okay, so let's just say you have like x to the 1/2 power on like one side of the equation and then like something else on the other side. Could you just square root both sides to cancel the 1/2 power?
Not quite. We'll get into more stuff like that when we get like really into exponential functions later this year. It has to, you have to use exponent rules to kind of manipulate stuff. Okay? All right. The square root of x to the 5th. The square root of x to the 5th. How could I rewrite that as a fractional, with a fractional exponent? X to the 5/2 power. Because remember, there's a 2 here for a square root. How could I rewrite the square root of 16 with an exponent? How could I rewrite this exact thing with an exponent? No. 16 to the 1/2 power. Because remember, here's the power of 1. The index is 2. What's the answer? What is 16 to the 1/2 power? 4.
So that's an
Oh, so it's just not fully simplified.
Yeah, the 16 to the 1/2 is just us practicing rewriting it.
Okay.
The answer is 4. Yeah.
So if you were given like 16, like in the number 3, like 16 to the 5/2 power, how would you like figure out what number that actually is?
We'll talk about that in just a little bit. This is the answer I'd be looking for on that. 4. Yep. All right, x to the 2/3 power. Now I want to rewrite that using a radical. So the numerator stays your power, so it's x squared. The denominator is the index of your radical. So you could write this as the cube root of x squared, or you can write this as the cube root of x squared. These mean exactly the same thing, and it's just going to be based on the problem. Sometimes it might be beneficial to take the root first, then raise it to a power. Other times it might be beneficial to raise it to a power, then take the root. You just got to kind of see how it plays out. But you've got to be comfortable recognizing that these are the exact same thing. Okay?
How would changing to like from the root to the power?
I'm sorry?
How would like going from the square root to the power? Like how would that?
Like, why would you want to use this one sometimes? Because say I'm giving you a big number, like 27 or something. You might not know what the square of 27 is and then the cube root of that number is. But if you take the cube root first, your number gets smaller and then you can square it. So it's just going to depend on the problem.
Like if you get a problem, like is it say number 5, x is 10. Like how would you find the answer without like changing it to 3? Like if it's just 10 to the power to the 2/3 power, can you find out what the answer is?
I mean, do you know what the cube root of 10 is? Or do you know what the cube root of 100 is? So there's no simplified answer of that. 10 to the 2/3 would be the most simplified answer.
But then you can change it to this. You get a more simplified answer?
Are you saying are you asking is this more simplified than this?
Yeah.
No, those are equally simplified. It just depends on what the problem is asking you for. Okay? All right, look at 10 to the 1/2 power, number 6. How could I rewrite that using a radical? Yeah, I could rewrite this as the square root of 100. And what is the square root of 100? 10. All right, let's simplify some values. Negative 8, the quantity raised to the 1/3 power. Good. So this is the same as the cube root of negative 8. Are we allowed to take the cube root of a negative number?
Yes. Yes.
Yes. Why?
Because once you divide it again,
No, it has nothing to do with imaginary.
once you divide it again, it'll go to the positive.
Yeah, think about the cube root parent function. The cube root parent function has an infinite domain. It extends forever and ever in both directions. You can take the cube root of any number you'd like. Okay? Could we take the square root of negative 8 and get a real number answer? No, we can't. You can only take odd roots of negative numbers. You're only allowed to take odd roots of negative numbers. That might be something you want to jot down. You're only allowed to take odd roots of negative numbers. You're never allowed to take an even root of a negative number. It'll be a non-real answer. Odd roots of a negative number.
R-O-O-T. It's R-O-U-T. Route. And it has
Okay, what is the cube root of negative 8? Negative 2. All right, look at number 9. 121 to the negative 1/2 power. I'm going to deal with this negative first. What does the negative tell me to do? This is 1 over 121 to the 1/2 power. Oh, sorry, the 8. I have no idea. Good. Can't tell you. What is 121 to the 1/2 power? Yeah, so that's the same as 1 over the square root of 121, which is 1 over 11. I'm sorry? No, this is a fraction because of this negative exponent. Okay, then go with it. All right, negative 16 to the 1/4 power. What is the base of our power?
16.
Just 16. Why not negative? Yeah, look up here. There were parentheses with the 8. This is negative 16 to the 1/4. 16 to the 1/4 is the same as what?
The fourth root.
The 4th root of 16. The opposite of that. What is the 4th root of 16? 2. So this is negative 2.
Can we do that on a calculator? Like the fourth root or something?
I mean, you can.
Just like cooking.
Huh?
For bigger.
Yes, there is a way to check this on your calculator. But you can also just type it in raised to the 1/4 power, because now you know the same between the 4th root and the power. Hence, why these questions are non-calculator.
Oh, they're not. Okay.
Because you can just type it in and ask your calculator to do it. So, look at number 11. 8 to the 2/3 power. How would I rewrite that? Cube root of 8 squared. You can either put the squared inside, right there, or you could say the cube root of 8, the quantity squared. It's totally up to you, and it totally depends on each individual problem. On this specific problem, we know the values either way. Up to you which one makes more sense. I'm sorry?
There's no 8.
I know. I said I didn't know where 8 went. It disappeared somewhere. I'd be happy to make up another problem if you'd like.
Yeah. Wait, why don't we just stay there? And that's the number.
All right, so what is 8 squared? This is the cube root of 64 is 4. Or we can start by taking the cube root of 8, which is 2 squared, and we get 4. Mm-hmm. Okay, 4x squared all raised to the 3/2 power. Couple different ways we could approach this. Ideas.
You take the square root of 4 to 4x to the 4 squared to the second power.
Okay. And then what? Parentheses.
To the second power.
To the 3rd power.
Oh.
The denominator, that 2, tells us to take the square root. The numerator tells us to cube it. Yeah.
Would that be, if you wrote it the other way, would you just put the 4x squared in parentheses and put the 3
Just like that.
under it? Yeah, okay.
Thank you. Excuse me. All right, so you can work these either way. It's up to you. I would probably lean towards taking the square root first because it's going to make anytime I can take the root first, I'm going to because it's going to make my number smaller and more manageable. Okay? So what is the square root of 4x squared?
2x.
This is 2x cubed, so that equals 8x cubed. All right, take a second and think about how we could approach number 13. Yeah.
Are you able to multiply these two?
You have to distribute the 4 to the 3/2 to the 4, and then that square addition.
Okay, ideas?
You did square 27 and then take the cube root of that.
You want to do that by hand?
No. I'm just saying you could do it.
I don't know the square of 27.
I was just saying you could do it.
You could do that. You're right. But if we're doing this by hand, that might not be our best method.
Change it to like, take the squared out.
Good. Change it to finding the cube root of 27, then squaring it. What's the cube root of 27? 3. 3 squared is 9. I hope you are realizing if you have forgotten all of your squares and cubes, you need to relearn them. You will be very sad in this unit if you do not know them. Blake, did you have a question?
I was just saying, because it said like the square root of 27 squared, couldn't you just cancel that out?
If it said the square root of 27 squared?
Yeah, it says, oh, it isn't.
You okay?
Yeah.
Okay. Let's look at 14. 125 to the negative 2/3 power. Okay, I want you to try that one. 125 to the negative 2/3 power. Refer back to number 9, number 11, all those good guys if you have questions. Give it a shot though.
You just said for us to do 14.
Yep. Compare your answer with someone sitting next to you.
You get 125th. Where's law number 1 day?
And then I tried to find the cube root of 125.
All right, looks like you guys did a great job.
Yeah.
Tatiana, can you tell me how you started number 14?
I put 125 under 1,
Okay.
and then I took the cube root,
So we rewrote it like that.
and then I took the cube root of 120.
And then you took the cube root of 125. Square it. What is the cube root of 125? So this is 1 over 5 squared, which is 125. Now, is that the only way to approach this problem? No, many of you approached it different ways, and that's totally fine. That's one of the nice parts about this topic. There's different paths. Okay? All right, let's look at 15. R squared t cubed over the 4th root of t cubed. Now, our goal is to get this a little more simplified. So what might we do? What do you mean get rid of it? Okay, so you see that we've got t's in there, and we're going to want to maybe subtract our exponents at some point. But we've got to rewrite the 4th root of t cubed first. How would we do that? Okay, so we would have r squared over t cubed over what? T to the 3/4. Y'all see that? Now we are able to subtract our exponents because we have bases that are the same being divided by each other. So let's think about if I've got 3 minus 3/4. How could I think of 3/4? 12/4. So 12/4 minus 3/4 is 9/4. So what am I going to end up with? R squared times t to the 9/4. Yeah, you can leave it like this, or you can rewrite it as the 4th root of t to the 9th times r squared.
So they're both just as simplified?
Yep. They're both just as simplified.
Oh.
All right. Y to the negative 3/8 raised to the power of negative 4/9. W to the negative 3/8 raised to the negative 4/9. You could tell me what to do. What do you think we should do?
Multiply the exponents.
Multiply the exponents. I think that'd be a great plan.
So you would have put 1 over it all?
You could, but then again, you have another negative out here, so you'd end up doing it again. So, yes, you could definitely get there that way. This just might be a little bit more streamlined of an approach. Okay? So this would be negative 3/8 times negative 4/9 because this is a power to a power, so we're multiplying. Now when we multiply fractions, what are we allowed to do? We can reduce, right? So 3 goes into 3 one time, 3 goes into 9 3 times. 4 goes into 4 once, 4 goes into 8 twice. Okay. So we get w to the negative 1 times negative 1 is positive 1 over 6. So you could write your answer as that, or you could write your answer as the 6th root of w if you really want to. I mean, if it starts off with exponents, I would probably leave it just with exponents. All right, let's look at 17. Take a sec and get that copied down. On a problem like this, my first goal is going to be to simplify the inside of my parentheses as much as I possibly can. So I know that I can move x to the negative 10th up to the top, right? Make that x to the positive 10th. Then I've got x to the negative 4/5 minus x, or over n to the 2/5. Yeah, so I could bring the end of the 4/5 down, and then what would I end up doing with 4/5 and 2/5? Add them. So we would have n to what power? 6/5. And all of that is being raised to the negative 5. All right, what does the negative allow us to do? Flip it. Okay, and then what are we going to do? Distribute the 5. Good. So what am I going to get? Nope. Mm-mm. These are not the same basis, so you can't do anything else to simplify this. Yes?
So how did you go from step 27?
Here to here? I moved x to the negative 10th up because that negative exponent tells me I can move it up and turn it into a positive. I took n to the negative 4/5 and I moved it down. So then it became n to the 4/5 times n to the 2/5. And when I combine those, I get n to the 6/5.
So you didn't have to change your 5 on the outside, change the negative 5 to a 5?
No, because I wasn't dealing with this negative 5 yet. I was only trying to simplify the inside first. I didn't deal with the negative 5 until the third step.
I didn't.
You could have started by flipping. That's fine. Okay. All right. Any other questions on this one? All right. Let's look at these last two. The cube root of the square root of 27. All right. So I want to try and get this simplified a little bit. Do I know the square root of 27? No. How could I maybe rewrite the cube root of all of this to help me? To the 1/3 power. Good. How could I rewrite the square root of 27? That's rewriting 27, but it's not rewriting the square root of 27. 27 to the 1/2 power. Here's the 1/3 power. So then what could you do with 1/2 and 1/3? Multiply them. So this is 27 to the 1/6 power. You could also write this as the 6th root of 27.
So does the 1/3 not go to 27 also?
What do you mean, go to?
Does it to 27
The 27 is attached to the 1/2. 27 is the base of 1/2. So anytime you have a power to a power, you keep your same base and you multiply your exponents. Like,
couldn't you like multiply the cube root by the square root and you get a 6/3? You multiply 3 by
but
2.
this is the reasoning why that
Oh,
works. So I'm showing you the behind.
Whenever do these on quiz or a test, do you want to start those or just one?
Yeah, Sean's fine. Just pay attention because the instructions might say use only rational exponents or leave your answer in radical form or something like that. Okay? All right, last one. F of x equals x to the 2/3 plus x to the -3rd for f of -8. Yes, sir.
The rational exponent is the one that was on the left side.
Yeah, a rational exponent means you want a fraction as your exponent. So like 1/6, 3/2, stuff like that. It would say radicals. Okay. Looking at number 19, what does f of -8 tell me to do? Yeah, plug in -8 for x. All right, let's start with -8 to the 2/3.
Use the cube root of -8 squared.
Okay. And what is the cube root of -8? -2 squared. Everyone okay with that? All right, let's go over here. -8 to the -3rd power. All right, so plus 1 over -8 cubed. Anyone remember what 8 cubed is? Very good, 512. Is it going to be positive or negative?
Negative.
So we essentially get 4 minus 1 over 512. Now we would need to get a common denominator, and for a situation like that, that would be something you would have a computation for. So I'll go ahead and tell you that if you get 512 as your common denominator, you're going to get 2048 over 512 minus 1 over 512, which would give us 2047 over 512.